Okay, welcome. Hi, everyone. My name is Rachel Burson, and I am joined here by my colleague Caleb and Naveed, and we're going to be sharing a little bit about Carnegie Mellon University, the Robotics Institute, and doing a deep dive with the RI Summer Scholar Program and this opportunity. And I'm really delighted that Caleb is able to join today. He was part of the Summer Scholar Program for 2 summers and really has tremendous insights into what is the process like to apply, how can we get started, and what does it look like? And he's been with 2 different labs. So Caleb, would you like to introduce yourself and welcome those that are joining us?
Hello, everybody. Welcome to the session. My name is Caleb, as Rachel said, and I was part of the riss 2020 as Dr. I joined the Argo AI lab with Dr. Joan Dolan, and then the second summer I joined Air lab with Sebastian Scherer. So I'll be sharing my work later on as well.
Awesome, wonderful. And just a few housekeeping things throughout the session. I'll be dropping into our YouTube stream the link to ask questions, and while Caleb is presenting, I'm going to check on those questions and we'll answer some of the top questions that come in towards the end of the session. So let's get an idea first of what riss is and where it's located. So Carnegie Mellon University, we're located in the eastern part of the United States in Pittsburgh, Pennsylvania, and Carnegie Mellon is a university that is world famous, top ranked for many different areas. Today, we'll be talking about how this supports your experience with the RI Summer Scholar Program and what it means to be here at Carnegie Mellon University. So the Robotics Institute is really a center of so many firsts. There have been pioneers that it's the first academic program in the world for robotics. So it is the first robotics department in the world. We're one of the world's largest university affiliated research groups, launched a PhD program, just so many firsts around robotics, just really world leaders. And what we've done is we've launched the Carnegie Mellon Robotics Institute Summer Scholar Program in 2006 to try to give students from around the world an opportunity to come to Carnegie Mellon to explore this environment and really to explore different application areas and research in robotics. So the Institute is really, really huge. And what riss does is it provides a platform for students to really have that grounding to be able to explore more of the Institute. So we'll be talking about what is the Summer Scholar experience. You're going to learn a lot of this through hearing about the research and experiences that Caleb has had with the Robotics Institute. And then we'll go into some specifics about applying and giving you some hints there. There's a lot of information in the FAQs, the frequently asked questions on the website, and there's some hints, and we will be offering 2 more sessions in the new year for last questions. One of the things that I'm especially excited about is that over the last 2 years, because of the pandemic, we've been remote. So we've continued to support emerging scholars and their access to robotics research and experiences through a virtual format. This summer, we will be in person in Carnegie Mellon's Pittsburgh campus, and we'll be bringing together opportunities for students and others to come together to explore in robotics. We often get questions about whether, who can participate in the Summer Scholar Program and what its purposes are and what the experience is like. So before I turn it over to Caleb, I'd like to address a few of these questions. One is that the program is global. This means that students from around the world that are interested in robotics have the opportunity to apply to the Robotics Institute. You do not need to be physically present when you are applying. So you could be studying at a university overseas, you could be studying at a university in the US. There are supports and systems within Carnegie Mellon to help to bring international students to the campus in the summer. So there's not a problem there. There are scholarships and supports that are either in partnership with sponsors or directly from the Institute to try to support students in their exploration with us. The Summer Scholar Program, when you're thinking about it, there's really three different areas. It's guided research. So rather than proposing a project, what I really want you to think about doing is looking at the riss research showcase and thinking about how you may be adding on to that research, how your preparation would prepare you to make strong contributions. You'll be with a individual lab, as Caleb was saying. He was with Dr. John Dolan's lab the first year, and then the second year with the Air Lab with Dr. Sebastian Scherer. In each one of those experiences, you have a research mentor and you have a lab that you're working with on a specific project. In addition to that, and that's where the professional development comes in, we want you to explore different possibilities in robotics research and applications in industry. And so we host a series of, when we're in person, visits and conversations to help you to really explore and see the larger field of robotics and AI. It will also help you to contextualize and place where your interests are within these fields as well. And we think it's great when you discover, one, you love what you originally came in with and want to continue in that track further, or two, you've discovered something that is even more exciting and you're going to pivot and shift after the program into new areas. We try to provide extensive supports, and this is the third piece, is that it's really a learning journey for all of us. We're coming together and we're trying to support and design a program and experience that really benefits everyone, and that's all of the stakeholders that are supporting the scholars and thinking about how to help you move toward your next steps. And there will be somewhere between around 40 students that will be participating this summer, and each one will have different preparation. Each one will have a variety of experiences, but we'll be united by our curiosity. We'll be united by our deep interest in robotics and AI and exploring those fields. I'd like to welcome Caleb again and turn it over to him.
Thanks, Rachel. I'll share my screen now. Right, can you see it? Okay. All right, so as Rachel said earlier, I was part of the riss 2020 and riss 2021. So I'll be mostly sharing about these two experiences, about what I did, what was the motivation behind the research, and what were my takeaways, and what was my overall impression of the riss as well. So to start with the riss 2020 experience, I mainly worked on this project called Trajectory Planning for Autonomous Vehicles using hierarchical reinforcement learning. So in this summer, I was part of the Argo AI lab as part of Dr. John Dolan's lab, and he's a wonderful human being, and the lab experience was amazing. I think I really liked everybody in the lab as well. So what was the motivation behind this work as well? So we basically worked on autonomous vehicles, and there are three things we try to cover in this work. The first one is that the current planning and decision-making framework for autonomous vehicles lack three main things. The first is that they don't have generalizability guarantees, which means that we want to make sure that the algorithms we develop for autonomous vehicles are able to cover more scenarios as well. They're not just limited to one scenario. For example, lane change, we want to make sure that they can be applied to different scenarios. And then they should have this ability to handle noisy sensor values, which is, the world is never perfect. You might get rainy seasons, or your perception system might, get erroneous as well. So you want to make sure that the algorithms you develop are robust and are able to cover for those erroneous things as well. And thirdly, you want to make sure that the autonomous driving is smooth and stable at the same time as well. There are no acceleration or deceleration, constraint violations as well. So I want to make sure. So in order to address the first thing, my lab was already working on reinforcement learning. So I was basically building on that. I wasn't, coming up with a new whole project, but I was basically working on building up on their previous work. So they were working on reinforcement learning, and reinforcement learning is kind of a machine learning in where an agent, which is a robot, learns through experience, and there's a thing called reward. which you get from the environment when you from the environment as you like experience different things in the environment, and you learn from that. So, but the problem was that how can we improve these reinforcement learning methods as well to handle the above mentioned issues that I already said: generalizability, ability to handle noisy sensor values, and smooth and stable driving. So this was the overall work I did. This is my poster from the risk experience. I wouldn't go into the exact details of everything. You can always go to the risk website or my homepage to look at this, like the details. I have a video there as well. But I'll just say that, okay, I basically proposed three things here. First was that instead of using reinforcement learning, I use the hierarchical reinforcement learning, in which we give our algorithm a modular structure. We have high-level options and low-level actions. So the overall policy is divided into high-level options and low-level goals as well, high-level goals and low-level actions. Secondly, we use LSTM to handle the noisy sensor values. Instead of learning from just state, we use like a history of state observations instead of using the most recent one, because if we use a history, then we can generate some trends as well, which our model can use to learn. Thirdly, we use a PID controller to cover the stability and smoothness issue. Autonomous driving, we want to make sure that our controller can follow all the constraints, and we want to make sure that our car can stay in the lane as well. In order to, so for this particular algorithm, we called it robust HRL, and we tested our algorithm in the Carla simulator. I developed another simulator as well for initial testing, but then later on, we use a Carla simulator to test everything, and our algorithm actually performed 7 to 8% better than the previous methods. So which was very encouraging to see as well. And this work was actually published in IEEE ITSC later on as well. I worked almost for like 9 months on this project. It was made mostly during the summer race as well, and then I continued in the semester as well. Second one was my race 2021 experience. So why did I change lab? I changed lab because, you know, from like suggestion from some of the faculty members as well, they suggested me to explore different research areas before I go for the graduate studies. So that was the reason why I changed the lab. I worked in the air lab with Sebastian Scherer, and my project was informative and fast exploration planning using UAV for reconnaissance operations. So the main motivation behind this was in the search and rescue operations, there are two main things that you are trying to do, or the robot is trying to do. The first one is data acquisition, which is how can you gather information about the area or about certain things, or even about, for example, in search and rescue operations, you can look for different people who are injured there as well. So you want to make sure that you gather data. And the second one is that you want to make sure that you can search the space as fast as possible as well. So these two tasks have to be done, at the same time, but they actually conflict each other sometimes as well. So you want to make sure that you have a balance between these two. Like when it is needed, you can explore faster. But at the same time, you want to make sure that you stop and look at certain things, in that space as well, to make sure that you don't miss any important information, because it can save lives. So our goal in this work was to develop a framework that ensures and prioritizes information gain while maintaining fast exploration. So in this work, I introduced I basically developed a method called prioritize fuel. So it was built on a previous method, which was fuel, which was developed by a university in Hong Kong, and we actually leveraged that particular method and built our model on that. So in the original fuel algorithm, the distinguishing feature about that algorithm was that it had a very good fast acceleration rate. As their name suggests, they named it fuel algorithm, which is fast UAV acceleration. So they already ensured fast acceleration rate. So what we wanted to do was that we wanted to add a layer into this algorithm and want to make sure that it can, prioritize information gain when needed over the fast acceleration rate as well. We want to make sure that we try to balance these two together. So in this work, I introduced 2 to 3 things into the original fuel algorithm. The first one was the FPQ structure, which is the frontier priority queue, to store information about high priority clusters. So which we can store in our algorithm in our database to even give more priority to while exploring the region. And the second one was the hierarchical structure. which was to make sure that we can balance between exploration planning and informative planning at the same time. The results were very encouraging. We actually improved the data acquisition by 2 times, which is almost 47%, as I remember. And then we were able to have the same exploration rate as the original fuel algorithm. So which was a win-win situation for us. We were able to create a better version of fuel algorithm in which our exploration rate was same, but we were able to give, we were able to decrease the data acquisition time by 47%. So this was all our work I did in the summer. But so one thing I wanted to mention here as well, that in the second summer, riss 2021, I was working on 2 things. So first one was research, and the second one was simulation development as well. So the lab at that time needed they had some urgent needs in the simulation development team. So I helped the simulation development as well in the initial part for almost like 25 days. And later on, I moved to full-time research. Before I was doing more like a literature review and other things as well. So you need to keep that in mind as well, that you might do different kind of work based on what lab needs as well. Because after all, you will be contributing to the work in the lab, and they will help you with that. So what was my bigger research picture overall? Like what were my takeaways from these 2 experiences? So the first one was that reinforcement learning has the potential to create human level intelligence. This is what I learned, the overall the one line I learned from my first research experience. Why was it? Because it is experiential. This is how humans learn, and that it has the ability to generate optimal and generalizable behaviors. And thirdly, it's task adaptive, which is actually what we want in the robots as well. If we want to make them very impactful in the real world, we want to make sure that they have these 3 things together. We want to make sure that they can learn, continuously, and they can generate optimal and generalizable behaviors, and they're task adaptive. Second takeaway, which was from my second research experience, was that there are a lot of work in planning, robotic planning, and behaviors in which we can actually use reinforcement learning instead of classic optimization to obtain optimality and generalizability guarantees. Which was very interesting to see that I was able to connect the 2 research experiences together, and was able to come up with the idea that there's some work that I can actually improve based on my previous understanding of the topic as well. But at the same time, RL has different concerns, which is related to safety, stability. So that's why RL is not currently in a position to be implemented in the real world applications. If you read a lot of work about RL, it's mostly in the simulations. Very limited work is done in the field as well. So there are a lot of stability and safety guarantees. And this is something that I'm looking forward to in my graduate studies to address. So overall, riss gave me understanding of the reinforcement learning or even robotic planning and behavior decision making, but it also enabled me to see that what I actually wanted to do in my later work as well. Sorry. So the third one is that I think I had this question as well when I started doing research, was that why research? Why do I need to do research? And the main question is that sometimes what we implement in the research might not be applicable to the real world applications. I don't think that's true. I think like if you look at CMU, they focus a lot on applied research, and they're actually solving a lot of world problems as well. So research for me is an opportunity to even address bigger world problems. For example, my work on the second summer was mostly on addressing the problem of safety of the rescue operations. So if we can improve the overall framework of rescue operations, then we can probably save lives. So that's probably a very big impact, I think. So you have an opportunity to address those issues by making those algorithms better. Second, I think it's very personal. I don't know, like a lot of people might have different things, but I think it enhances your ability to think critically as well. Because when you work on a research project, there are different things you need to consider. You need to consider, a complete picture. You need to consider, okay, if I'm making this A thing work, then B thing might not work as well. So you need to make sure that how can you, combine things together as well. So you need to think of different things before, making a final algorithm. So it enhances your ability to think critically, and you can always use the skill in other, areas as well. Thirdly, it makes you patient. I think I learned a lot from that as well. That sometimes things don't work. Especially my first research experience, because I was coming from a background with no research experience at all. So I was not used to apply, doing research, and then research is sometimes very cruel. You don't get any results for like a month and a month and a half, and then but you need to be like patient. You need to be continuous in your efforts as well. Try to like do your best, and then hopefully the results will come as well. So the fourth is like why risk, why this research, this program. So I think there are four things that I would say, matter to me, like when I was part of the risk, which was the main reason why, like I would say, I attended risk, and there were the main takeaways. So it's a platform to know about current technology and opportunities. Risk will have different, first there's like a lot of work that is already being done there, You wouldn't be like so you would be part of one lab. You would be, you would get to know more about that work as well. But there will be like seminars or workshops where you will be taught on different things which are happening in the world right now, and how technology and robotics can actually address that. So it's a great platform. Second is the opportunity to learn from robotics leader. I think this is probably the biggest, because I think what I noticed out of these two research experiences was that, Carnegie Mellon and, staff is really, really helpful. I think one sentence that I think I heard a lot was that, Caleb, how can we support you? How can we help you? So I think that's like, that's the genuine desire in people to help you grow. They're very selfless in that. So I think especially my first research experience, Dr. John Dolan had a major impact on me. I think how I view research as well. So I think I learned a lot from him as well. So I think it's a great opportunity to even learn from robotics leader, and they're very helpful. There will be a lot of smart people that you can learn from. So make sure you count on that. Third, it's a very good networking platform. You'll be able to meet a lot of people, like very smart people working on very different problems, which have the potential to even revolutionize the world as well. So it's a great platform for you to network with people, and you can always initiate different things. And fourth, I think it's a major part of the risk, but I think knowing how to do research effectively. There will be different workshops, on like how to make a video, how to make a effective poster, how to write papers effectively, what not to write, what to write, and how to even communicate your idea as well. I think even if we know the idea in head, it's hard to like sometimes communicate that well out there. So I think risk does that very beautifully, like it teaches you very beautifully in that. So that was my main risk, I think, takeaways. I think that's all from me. Like I would be happy to take your questions. You can scan this QR code if you want to know more about my work, or you can email me at calebandnavid@gmail.com. Thanks.
Great. And Caleb, we can leave that up so that those that are joining us, they can see that. And then if they'd like, they can reach out to you directly. So thank you for sharing those experiences of the journey, of the research, and the importance of walking into this space. The questions that are really front and center for so many of the students is that may be considering applying is about their how do I really shape the application? How can I stand out? And I think that both Caleb and I will say, please go to the research showcase, the risk research showcase. That is a tool, that is a support there for you, and it's meant to help you find out what types of research projects might be possible, because as Caleb was saying, you're adding to that. So to be able to have an effective application, we need to know where your interests are and what you're adding to, right? So you might have a broad interest in robotics. Make it concrete by visiting the research showcase, looking at the prior projects and really connecting in. Talk about your preparation, talk about how you can contribute to that. There are many different mentors. Caleb, I would suggest that individuals look at multiple years, like at least 3 years, because in the last 2 years we were remote, so the projects might have been a little bit different, and you want to go back at least 1 year. It's interesting. Caleb and I have known each other for 2 years, and we've had the possibility to meet one time in person years and years ago before he was a summer scholar. But we've not had the opportunity to spend a full summer together, and we're really looking forward to in the future that being a possibility for a significant time for him to be here in Pittsburgh, and that's what we're planning on it and hoping for. But please, if there is a really the best way, because people were saying, is there something specific? Yes. Tie it back to the research that's being done within riss, show that interest, look at the posters, the videos, and then the papers as well. Look at what the faculty members are doing. I would say that some information might be included on the faculty members' websites, Caleb, but I think it might also be a good idea to go to like Google Scholar to get more up to date or more recent things as well, to see what they're doing, where are they presenting in conferences, who are they working with. And sometimes there's really exciting shifts in research, like they found a new application area or they're diving in further to something. And it's interesting also to see the progression of the research, right? And the directions and such, and things tie together so deeply. You mentioned that there is an opportunity to continue to do research. You mentioned doing a publication, and when someone may be thinking about applying, often they're thinking that maybe a publication in a high-level journal or conference is out of reach. But we want to really shift that and say, this is why there are so many workshops, so many supports about learning to present your research, learning to communicate what you're doing. And when you first, are there outcomes or successes that you've had that even surprise you now compared to when you first were applying, right?
Yeah.
Yeah.
I can totally relate to that. I mean, I remember, like, for example, when I started the riss, I was, how will I finish even the paper for riss journal? And then at the end, I ended up publishing a paper. So I think people are really supportive there. So yeah, that helps a lot.
It does. And you said something, I think Dr. John Dolan is a spectacular mentor. And I would absolutely agree that, very much interested in your growth. And that's why we do riss. Riss is, it's another example of our service is the Robotics Institute to the robotics community, because we know that there are so many fabulous students that maybe haven't had this opportunity yet. And this is really about providing those opportunities and those supports. And we have, an onboarding process to try to help students get to know each other, to learn about the environment, to get access to some of the tools they might need. During the summer, we work together, and Caleb will tell you there are so many workshops, there are so many presentations, it blows your mind. But the idea is look around, explore everything, right? It is fun. It really is fun. Sometimes it feels like it's too much, and at the end of it, we all look at the published journal, and it's amazing. It's amazing.
It's very satisfying.
Yeah, and so it doesn't end in August, right? So we continue to refine the papers and work on that, and that's intentional. There's some intentional supports there. There's an intentionality about the peer reviews. There's an intentionality about the peer driven. You will merge with a skill set, which is how do I prepare and write about what I'm doing for various audiences? How do I prepare a paper for publication? How do I prepare a poster for a conference? How do I serve on a committee for a journal? I mean, these are all things we're trying to create opportunities for us to learn and do together. So really want to thank Caleb and give you the last words. Are there some words of encouragement? Are there some pitfalls? Are there some things that as someone's applying or preparing to apply that you'd like them to keep in mind?
Right. I think you did a very beautiful job, like explaining everything. But I would just say that a lot of people might be thinking about should I apply or should I not? I do not have any research experience. I do not have like a top high GPA. So I think you should go and apply, because you don't need a research experience coming into the riss. You just need to have like a ability to even think as well. You just need to be like courageous to even take on challenges. You definitely need some of the skills which are more transferable skills. For example, any programming classes you took, or you can always go and check out Coursera, EDX, or your different online MOOC platforms as well. Before coming to riss, I did like a specialization in robotics, which was mainly online. So I think you can explore that as well. So I would just encourage everybody here to just apply. Don't be like we do not have like a research experience or everything. Just make sure that you can create your own picture, and make sure that you show yourself that what you really are, how you have contributed in the past as well. It could be tutoring, it could be other things as well. So just make sure that you apply. Yeah.
Awesome. Wonderful. Well, thank you everyone for joining us today. And we wish you the best of luck as you are finalizing your applications, and a really wonderful holiday and New Year's season. And hopefully there's time for rest and celebration for all. So thank you for joining us today.